So here we have a 4 sine x plus e to the x cosine x, yeah? And we have to use the annihilator method. Now, as far as the sine goes, it should be straightforward. You agree?
Yeah.
So sine x, the annihilator for sine x should, well, the derivative of sine is cosine, and the derivative of cosine, negative sine. So that would be d squared, the second derivative, plus the original, so plus 1.
Yeah.
So the annihilator for sine is d squared plus 1, because the second derivative of sine plus sine gets you 0.
Yeah.
Because they go cosine minus, they go sine, cosine, and then minus sine. So this is the first derivative, this is the second derivative. So this is d squared plus the original. If you add these two, you get 0. Okay, now we need the annihilator for e. Think about it. E to the x cosine. So let's do the derivatives here. So we will get e to the x minus e to the x cosine x. Oops. Yeah. Minus e to the x sine x plus the product rule. So the derivative of the first is just e to the x cosine x.
Yeah.
Okay.
Yeah.
Now, clearly you can't make those go away because you've had another sign here. So let's do it again one more time. So this is the first derivative. So this is the, let's just say y prime. Okay.
Yeah.
Let's find y double prime. So we might need some more space here. So y double prime. So product rule on the first, minus e to the x cosine x, right?
Yeah.
Minus e to the x sine x. And then on the second one, you will get minus e to the x sine x.
Same thing.
As the first one, yeah. Plus e to the x cosine x. So are there any like terms here? Yeah, these two go away. And you get here minus 2 e to the x sine x. Okay, so this looks promising because what this means is that if you multiply the first derivative by negative 2, so that would get you 2e, right? Because that would get you 2e to the sine x.
Yeah.
And you add it to the second derivative, that minus 2e to the x sine x plus 2e to the x sine x. That takes care of these two, right? But then you also have plus e to the x cosine x, right? Yeah. Because when you multiply, it becomes negative 2 e to the x cosine x. So you'd have to multiply the original by 2, so plus 2. So this seems to annihilate e to the x cosine x. D squared minus 2d plus 2. You get it? Because this is the second. Here, I could show you how each one of those terms work out. So here, d squared will be minus 2e to the x sine x. Yeah?
Yeah.
Minus 2d will be minus 2 times the first derivative. So you will get 2e to the x sine x minus 2e to the x cosine x. So this and this go away. And this 2 here multiplies your original by 2, so you get 2e to the x cosine x. And this takes care of that. And you get 0. So that means the annihilator for e to the x cosine x is this guy right here. Okay? So now, having said that, we've got d squared plus 1 originally, and here we've got d squared minus 2d plus 2, and we're going to apply this on the differential equation. The original differential equation has in it d squared plus 1, so we have another d squared plus 1, which is, notice, it's the same as this, okay? And if we apply this on the y, and then on the right hand side, of course, we're going to apply the d squared plus 1 times, here, let's move this a little bit to the left here. Okay, d squared plus 1 times d squared minus 2d plus 2. And we're going to apply this on the right hand side, which is 4 sine x plus e to the x cosine x. So 4 sine x plus e to the x cosine x. And of course, if everything is done correctly, you are guaranteed that this side will be 0 if your annihilator is correct. So now we can write the characteristic equation, which is r squared plus 1 and another r squared plus 1. No? And now we have r squared minus 2r plus 2 equals 0. Now don't factor. Don't FOIL. Keep it factored. And now we're going to set each one equals 0. So we've got r squared plus 1 equals 0, which makes r equals r squared is minus 1, which makes r equals plus or minus I. Of course, the same exact thing goes to the second factor, plus or minus I. So you have repeating signs and cosine. And then the third one, r squared so here you've got r to be minus 4 minus 8 is minus 4. Square root of minus 4 is 2i. All over this is here is just a 2, all over 2. So we get 1 plus or minus 2i. Okay? So far we have this. So that means what? That means y general, let's write y general here. Y general will be you have the plus and the minus I, so that gets you C1 cosine x plus C2 sine x, right? Because these are complex conjugates. Okay, and then you have them again one more time, so you get C3 cosine x, but this time you multiply it by x because they're repeating, because the r squared plus 1 repeats. Plus C4 x sine x. So you multiply the sine and cosine terms by x because they repeat. And then we have this second guy here. There's no more room, so I'm going to continue it here. So plus the real part of the r gets you the exponential term. So this is e to the x. And the imaginary part gets you the sines and cosines. So you get c, or let's call these just the a cosine 2x. Now those are not repeating because it's no longer an x, it's a 2x now.
Yeah.
Actually, wait, it is an x. I made a mistake here. It is an x. This is 1 plus or minus I because you divide by 2. Okay, so but nonetheless, it's not repeating because it's multiplied by an exponential term. So we get, so we'll continue here, a cosine x plus b sine x. Okay, so you can see it's a long general solution here. So this is the general solution to our differential equation. Now, to find the complementary, okay, solve the homogeneous differential equation. So that happens by just setting the right-hand side equal to 0. I mean, the right-hand side equal to 0. So this is just y double prime plus y equals 0. Characteristic equation is r squared plus 1 equals 0, which makes r equals plus or minus I, right? Which means y complementary is the sines and cosines because these are complex conjugates. So we get a cosine x plus b sine x. So this is y complementary, which is part of your general. So take that out. The remaining terms in red are the y particular. So therefore, so let's write this in a different color. Yeah. So therefore, y particular will be everything here in red except the cosine and sine because this happened to be your complementary. So C3 cosine C3x cosine x, yeah, plus C4 x sine x plus the bottom one with the exponential, so e to the x times a cosine x plus b sine x. So this is the complementary solution of your differential equation. So you just subtract out the y complementary from y general, you get y particular. The trickiest part was finding the annihilator for e to the x cosine x. And the way you do this is you start taking derivatives till you get similar terms. And you multiply by constants. Those numbers, whatever numbers it takes, so that when you add them up, you actually get 0. You annihilate the entire non-homogeneous term.
Right. Yeah.
But that's pretty much it.
I got it. All right. I guess. Yes.